Everybody see that title, the atmospheric methane?
Yep.
Yes.
Okay.
I see it.
So this is kind of the outline. The big topic is number 3. We'll get to that. My objective, so I thought I'd give you kind of a spoiler alert up front. My objective is not to get into too much of the science of methane and get to the issue, which is shifting or in introducing methane as a priority versus just pure CO2. Anyway, so it's kind of a background to understand the new focus in parallel to CO2, which was really highlighted and became a major emphasis of the COP26 back in November, if you recall, both for the US and for the international organizations. So it's really been a major shift or an awareness, whatever. One thing along the way here, this word anthropogenic, I think it was a created word. I'm not sure, but you'll see, I mean, by the environmental people, but you'll see that frequently used in the media and in some of the slides. All right, so my objective again is to deal with the major issues where methane comes from. There are obviously dozens, if not hundreds, of sources of methane, but the 3 biggies are natural gas. And interestingly, having discussed this with a few people over the last week or so, it's amazing how many people don't realize natural gas is methane. And it isn't 100%, but it's primarily methane. And of course, the livestock.
Some of us call it devil's breath.
Because?
Because it's bad stuff.
Oh, okay. Then, of course, I was not aware that from the livestock, it's both ends. And I think that's because of the what the ruminating stomachs, that front stomach can't obviously run the gas out the back, so it runs it out the front. So it's a bi-directional kind of a problem. And of course, landfill. And I also did not realize that landfill is only half gas. And the rest is water. And so interesting, I would have, it's amazing when you see the flaring going off at landfills, how well that actually works. So here's the natural gas breakdown. And it depends on where the natural gas comes out of the earth, whether you can see all the percentages fly all over the place, but it's largely kind of 80%, 80, 90% methane. And cows, of the cute little picture here showing that it is the front and the back creating a little more variety with the manure and its decomposition. All right, so from a US standpoint, the sources, and again, these numbers float around depending on who you're talking to and who's doing the research and all that sort of thing. But you can see that from a mining from a hydrocarbon acquisition standpoint, you get, can you see my cursor here?
Yep.
Okay, you get the coal and you get the natural gas and you get the oil, and that gives you about 37%. Then you take the fermentation, basically cows or other animals, including humans, by the way, we just don't put out that much, and manure, and you mix those two together and you get about another third, 36%. And then landfills and others, the other being largely natural things in contrast to these kind of man-made or man-controlled sort of activities. And so if you do that, the 3 biggies that are part of the US, what is it actually called? It doesn't really matter. The methane reduction plan that came out of the November COP26 really focuses on these 3 big areas because they are the dominant and, more importantly, the most controllable ones. We're kind of not in much control over what happens out of the marshes, but we have much more control of what happens out of our mining activities, a little bit out of the livestock world, and a lot out of the landfill world.
Mert, could I ask a question at this point?
Sure.
We all know that fracking has increased the amount of leakage of methane. And I'm wondering if these numbers that you're giving us include fracking in these numbers?
Well, the answer is I don't know. My sense is the 30% over here in the natural gas and the petroleum side. The natural gas is kind of a new one because we weren't really that interested in collecting natural gas. And we weren't that interested in well, we were, but the US has become much more involved in that. So an interesting thing I'll show a little later, we are a small part of the world's problem anyway.
Yeah.
Not a small part, but we're not the dominant piece for sure. And so I'm not sure is the answer to that, Richard.
Okay, thank you.
I can tell you that this nice little pie I have here, there's if you Google a pie like this and then you look at the images, you'll come up with 30 different pies and they're all plus or minus. So it's hard to tell. So my point today is merely to put in kind of a relative perspective what the biggies are and what's in and out.
The fact that it's 2019 at least shows that it's pretty current. So appreciate those numbers.
Yeah. And they come out continuously. I forget which, I didn't include where that came from. Oh, that might have come out of the US one. Anyway, all right, so we talked about this one. Okay, so what is in those gases? Okay, so now we've got to the gases coming out, and where does methane fit in relative to carbon dioxide? And of course, we've all in the past had our focus decades ago on the fluorinated ones. Nitrous oxide is an interesting one, but that's a whole nother topic. It's a much smaller, but methane versus carbon dioxide, you see it's about an 8-to-1 ratio here. Later, I'll show for the world, that ratio is more like 5 or 6. So our methane is actually less than the world average, which is kind of interesting. So here's the different countries, the different regions of the world. And in this particular case, it's done in millions of tons. Often it shows up in teragrams. You'll see all kinds of interesting measurements, but this is magnitude in contrast to percentage. And I found a couple of things interesting here. For instance, here in the middle is North America. And you see that our biggie is oil and gas with a little bit, with some cows up here at the top. The blue, the lighter blue is the cows, and down here in this kind of teal green is oil and gas. If you look over here at China, it's coal. And you think, what does coal have to do with methane? And as I recall, I think the canary in the coal mine is a methane issue. And of course, if you're doing strip mining, all you're doing is just releasing tremendous amounts of gas without any interest for where it goes. So it's not surprising that China's coal production is a major contributor to methane in the world. And of course, they also have some agriculture up here at the top. Over here in Southeast Asia, I was surprised to see how much of that is actually agriculture. You come over here to Russia and the Middle East, and of course, that's where you get the oil and gas. And when you're drilling for oil, there's a lot of gas that comes out. And since it's for free, nobody pays for it. And at that point, they didn't want it. Just let it go into the atmosphere. So there's been a lot of methane release going on when you're really doing oil well drilling. I always wonder, when you see the oil wells kind of blast out when they drill the hole and they hit a pocket down in the earth. I'm wondering if that's methane as a gas creating the pressure. I can't, I don't know. But clearly there's a lot of methane that comes out of the oil, gas, and coal production. And those are the biggies we need to talk about. Europe, it's interesting that here we are, and I think we're like 10 or 15% of the world methane, which raises the interesting problem that when we talk about all the things we can do here, our impact is on the global climate is not going to be as dramatic as maybe we would hope. So we've got to get the rest of the world. So the COP26 and 27, which comes up here in a couple of months in Egypt, hopefully we can get some real emphasis on this. All right, before we leave sources, yeah, question?
Just a little question you have not yet addressed, but will presumably the relative greenhouse gas effectiveness of methane versus CO2?
That's where we're going on,
Okay.
on category 3, because that's the heart of this whole problem.
Okay, good.
But I thought along the way here, under just, you may have not have noticed way back there, one of the sources emerging is methane coming from under the ice, meaning the 2 caps.
Yeah.
When we punch holes in the dirt, the earth, for coal, oil, or gas, there's an opportunity for gas to get loose. Well, that same decomposed history is hiding under the ice on the 2 caps. And we don't need to drill a hole there, but as we're melting the ice on the 2 caps, it's just coming out uncontrollably. Interesting. And it's just starting to happen. But here's a really interesting little video. Let's see how this works. So do you see the screen go blank?
Nope.
Can you all see that?
Nope. I don't see any change yet.
I'm afraid, I was afraid of that. All right, so what I may need to do is stop share, reshare, and bring that video up. How about that? Did that help?
Yep.
You have a YouTube video up now?
Yep, it's great.
Yes.
Thank you.
All right, so let me blow it up full size. And then we'll have to test the volume here.
Standing on a frozen lake in interior Alaska.
How's the
Good.
volume go?
Good, perfect.
That was okay?
Yep.
All right, let me go back to playing. So where we are is some researchers from the University of Alaska Fairbanks.
Outside of the University of Alaska Fairbanks campus. And this ice is already about 20 centimeters thick. So as it's been freezing up, methane gas has been coming out of the bottom of the lake and getting trapped in the lake ice. If you look at the shore, you can see that there are lots of trees that are falling in the lake and they're dying. What's happening is the permafrost is thawing. And the ice that was in the ground, when it melts, causes the ground surface to collapse. Then the forest falls in and any organic matter, dead plant and animal remains that were in the permafrost, thaw out in the bottom of the lake. Microbes decompose it and it generates methane. And methane doesn't like to stay in water in solution. It forms bubbles, and those bubbles make their way to the surface. In the summertime, the bubbles pop and they enter the atmosphere. In the winter, however, this ice forms a cover on the surface of the lake, and the bubbles get trapped right under the ice, and then the ice thickens and freezes around them. And so what we have out here is like a time-lapse photograph of methane emissions from the lakes. Methane is a very potent greenhouse gas. A molecule of methane is 25 times stronger than carbon dioxide. Methane is formed in millions of lakes around the Arctic where permafrost is thawing. And each year, these lakes are emitting already tremendous amounts of methane. But when we look at how much carbon is in permafrost still frozen, and the potential for that permafrost to thaw in the future, we estimate that more than 10 times the amount of methane that's right now in the atmosphere will come out of these lakes.
Fascinating.
Yeah,
Very,
yeah.
very too.
So let me get back to the presentation. I figured that would be a little distracting, but kind of a cute little video. All right, are we back to the methane under ice video or screen?
Yeah.
Looks like Lewis wants to get in, Richard.
I just
You
let
got
him in. Just let him in.
Let him in, good. All right, before we leave the sources, another interesting terminology is this thing called methane slip. I don't know if you're familiar with that, but
No.
when you use a natural gas or biogas or any of the gases in a road vehicle, because of the temperatures in there, as it says here, due to combustion at these lower temperatures, it passes right straight throughout the exhaust system. And they call that methane slip. So quite a bit, and the marine engines, which run at a much higher temperature kind of consistently, it isn't as big a problem, but using gas in road vehicles is not the great benefit that we might have thought it was going to be. So then that's where this term comes from. All right, removals and sinks. So here's a kind of everything you want to know, but a little bit dense on information. So over here on the left is this anthropogenic, which means all the human causes or sources of methane. And then you have the natural sources of methane. The biggies in the human are the fossil, the livestock, and the landfill, at least in terms of what we can control. And then the natural resources. And here's this ice, the ice one that we just saw that cute little video on. And then, so my objective is to get to the sinks with a little background for.
Do you have any idea percentage-wise of anthropogenic versus natural?
Sort of. If you go back to the pie where there was the other,
Yes.
that's kind of the natural.
Okay.
Now there is some natural in the kind of the landfill, because there you pick up some of the wetlands kind of thing.
Okay. Okay.
and-
Thank you. I got it now.
Yeah, and the ocean is not a real good absorber of a lot of methane. The interesting thing I learned about the sinks is there's really only two serious ones, which is the atmosphere, higher and lower tropo and strato atmosphere, and a little bit of the soil, which comes over here to the naturals and then turns around and gets released again if we do something.
Yeah.
Either melt the ice or disturb the plants or dig around in the wetlands. And then you get over this conversion and deforestation. So even the absorption, the removal of methane into the soils kind of moves left and ends up with us letting it loose again. The two biggies, which is not surprising, is the atmosphere. And you may or may not realize that methane is about half the density of oxygen, nitrogen, basic air. And so consequently, it goes up and out fast, straight up. And the numbers, and here's where your comment about the global impact and the dissipation timeline, we talk about this 10-year lifespan for nitrogen, for methane.
Mhm.
And in the troposphere, that's true, or that's kind of the average. If it goes to the stratosphere, it's 10 times that lifespan. I found that very interesting. And those of you who have non-engineering type of degrees might understand this a lot more, but that's not an engineering, that wasn't part of engineering school, I guess is my point.
You could ask if it is less or equally greenhouse gas inducing in the stratosphere as opposed to the troposphere.
Oh, you're good. That's 2 slides from now.
Okay.
Okay, let's start with the percentages of which goes where. So here's where the absorption into the soil, which is a small percentage, of course, and much of that we turn around and turn loose. But the primary objective of this slide is to show that methane goes up into our atmosphere, which is why it is becoming so apparent that that is a critical natural or a greenhouse gas. So here's the stratosphere at 15%, and the troposphere at 80. Now we go to, what does that mean? So how do we learn those numbers? We've only learned them recently from spacecraft that are now analyzing what goes on in our atmosphere. And one of the things that is still missing is this measurement term. There is very little measurement about what goes on at the surface of the planet. So there's very little information about where methane is coming out of oil wells, gas wells, coal mining, or for that, we have a little better idea what's going on with cows and a pretty good idea what's going on with landfill. But when it comes to the hydrocarbon acquisition, coal, gas and oil, we have very little measurement going on. There's some local stuff where people run trucks by and kind of snoop around the side. But when all said and done, very little. All right, to your point, Richard, in that 15%, which is the high sphere, the methane breaks down into carbon dioxide and water, no big surprise there. And this is above the troposphere. And apparently, you all may understand this, both water and ice, which are formed up there, have an extremely efficient greenhouse effect. So that is why, as you recall, this one, the 10 years or the 9.6, whatever, in the troposphere and the 120 in the stratosphere is largely because when it gets up there, its impact is very dramatic to the greenhouse. And again, without satellite measurement and satellite information, a lot of this, I'm sure, was understood by scientists, but not by general public, policymakers, and the media. So this doesn't get talked about. But this is where the calculation of whether methane has a greenhouse, a global warming potential of 20, 30, 40, 50, 100 is because it depends on where it is and how it breaks down. That help? All right.
Yeah, it sounds like we should get rid of devil's breath.
That's for sure. So now we're going to go into the primary purpose, which is what's the impact? What's been
question?
Yep. What's the question?
When it's in the troposphere and has a greater impact, is that because of the crystallization of the water being reflective?
Well, you all talk among yourself. I have no clue. Good question. I just copied and pasted this and have no idea what it means. I know what it means from a global impact or from a climate warming standpoint, but why? Does anybody know the answer to his question? I'm not hearing anybody else answer your question either. So the answer
I wrote it in the chat. Water itself is a greenhouse gas.
Right?
Well, we all
Yeah.
know that, and it's very
Yeah.
good that it is, because if it weren't, we'd be really freezing.
That's right. And the devil's breath is necessary to help plants grow. Don't
Sure.
forget that. You've got to have CO2 for photosynthesis. So we don't want to get rid of it totally.
No.
Yeah.
No, when I said devil's breath, I meant methane. I meant methane.
Yeah.
Oh, okay. But natural gas, as he said, is mostly methane.
Yeah.
So
Yeah.
just keep that in mind. That's all.
Yeah. Well,
With the-
this is an interesting conversation that's just beginning to happen. For some reason or other, the focus, which is this one, has been on carbon dioxide. And there's a bunch of reasons. I'll give a couple of what I think are apparent reasons, but we need carbon dioxide. We probably at some point need methane. I don't know, the planet comes with it, so it's probably pretty important. It's the extreme of it, and it's the excess that's been created, not so much by the agriculture or the biomasses or even the history stored in the ground. It's this, to get to carbon dioxide, we burn hydrocarbons, and getting the hydrocarbons is man-made release of methane. It wasn't part of the original plan. And so it's interesting how the hydrocarbon industry as a source of energy has somewhat incidentally, maybe not accidentally, but incidentally, coincidentally, but unknown to most people, released methane. Anyway, okay, we'll keep going here. So unlike hydrocarbon fuels that burn and create then carbon dioxide and other and water, methane does it directly. So it doesn't have to go through a man-made process like most of the hydrocarbons to get to carbon dioxide and water. And unfortunately, it's largely invisible, particularly to the public and the media. And people drilling for oil could care about it. It's for free. They didn't pay for it in the first place, so let it go into the sky. And the coal mining people really don't care. In fact, other than they worry about it exploding in their minds, but Other than that, aerate the mine, strip mine, whatever. So it's invisible, and that's been that's why methane has not really been important. Unlike coal, oil, methane spills aren't gooey messes. So when methane is spilled out of an oil well or off of a coal mine, it's invisible, of course, and odorless until it gets scent is added to put it in your house. But other than that, it's pretty much odorless. So it doesn't create gooey messes, no heavy smoke, and no apparent physical damage. You don't get the birds all covered with oil. You don't get the slicks on the ocean, and you don't even have coal dust. You don't even have strip mining messes. I mean, it just, and that's part of the problem. It's not been something that people are aware of or thought about.
That video that you showed really demonstrated that well, Mert, from the University of Alaska. I mean,
Yeah.
Until they ignited that, they didn't know how much was coming out. They knew it might be, but that was pretty surprising to everybody.
So at the risk of being a little bit childish here, how many of you have sat around a campfire with a bunch of teenage boys? Do you ever recall seeing methane demonstrated at a campfire? Anybody say yes to that?
Yes.
There's one. So were you one of the creators or just the spectator?
A combination of both.
You want to explain to the group what that means?
No.
Okay.
Matter of rather than a cow doing it, it's just a matter of a human doing it and passing the gas, of course.
Right. Yeah. So most people don't realize that human gaseous excrements are just as flammable as cow. Anyway, enough on that. Anyway, so to your point, Richard, I use
more humans than cows.
yeah, that one. Fortunately, I don't think we put out as much as the ruminating cows because of their double stomach issue, but I don't know that. We definitely have them outnumbered, but whatever. But to your point, Richard, that's why I showed the ice video. I thought it was more appropriate than the campfire videos, but there's lots of really cool videos out there you can only imagine. Anyway, enough on all that. And of course, another thing that's been holding things up is that our human additions of organic material, whether it's in landfills or other places, unless you see a landfill with a flame blowing over it, it's really not obvious that that's creating great amounts of methane, and of course the manure. And now the rice paddies have been identified, and that's one of the things in that graph or that bar chart earlier where I showed all the different countries and regions, whatever. Rice paddies are listed in there as a major source because they're very wet and create a lot of methane, just because, much like a marsh or whatever, they're a great source of methane in those countries. We don't have many around here anymore, but anyway. All right.
Could I add a remark here?
Always.
One of the things that the press and the public in general don't pay much attention to is that methane, when it degrades spontaneously, as you've just been describing, it degrades into water vapor and CO2.
Yes.
And the CO2, while it might be less greenhouse gas forming compared to the methane that originated it, it stays around about 100 times longer in our atmosphere than the methane does. And so I'm not sure how you qualify that problem. People have talked about attacking the methane first because it's going to have a greenhouse gas effect and serious climate change within decades, whereas CO2 is less greenhouse gas forming, even though it lasts longer. We'll deal with it later like humans typically do. And so you have this balance between greenhouse gas induction qualities and duration. And they're different. They have different qualifiers and I'm not sure which is a worse problem. Do you have any
Well-
thoughts on that?
Well, we'll get to that.
Okay,
That is exactly the conversation, the analysis, the scientists talking, the creators of our energy sources in the hydrocarbon world have been talking about, and there's this real battle going on
okay.
because the hydrocarbon mining people would really rather not have to address the fact that they are the largest, easily solved, quickly solved source of a major source of climate warming. We'll get to that. So,
Okay.
okay, let's go on from this one. I think we're enough on that one. Although this is where the Arctic ice is, and like she said, if we keep melting the caps by warming the planet, there is this positive feedback system.
Mm,
And if the caps are being warmed by CO2, you get methane. It's like, and methane has a higher warming impact than CO2. And all of a sudden there's this CO2 methane going back and forth, which is more important? And the answer is both, clearly both. And that both is what's new. It used to just be CO2. And now people are saying, wait a minute, let's back up. There's another piece of this major puzzle. And that's this one, of course, and that is the global warming potential, the GWP they call it, but the global warming impact is not well understood. And that's both a scientific as well as a public media politician statement, because it is very complex. I mean, a couple of you have already mentioned a few factors. What happens between the stratosphere and the troposphere, and what happens when it breaks down and turns into CO2. And yes, it does dissipate much quicker than CO2, but not instantly. Consequently, if we're going to solve this problem in the short term, and we look at all the long-term potentials for, and I mentioned this to Richard in one of my emails, I get really upset when I hear about the goals for 2050, the goals for 2021. I mean, for 21. And I'm thinking, we need now goals, and there is one very readily available in this decade to put a major slowdown in potential in climate warming, and we are not, or have not, up until November of 21, the COP 26, have not even acknowledged it was a choice. This is where the fix is. Fixing the mining and distribution infrastructure, leakage, as well as all the other things we've talked about, doesn't create money-making businesses like the solar, the wind towers. A lot of those ideas are chock full of new businesses making new monies and new profits. And then on the negative side, not only does it not generate business, it does create expenses. No new technology is required. We just have to spend money and stop it. The livestock one's a lot harder because that involves changing human behavior. A little trickier. Not that it's hard. I mean, it is hard. Not that it's impossible, but when you look at this on a worldwide basis, and the bar chart I showed earlier, we can stop eating cows here in the United States, and that'll reduce maybe 1% of the problem. There's a bigger problem that needs to be solved, and livestock is not the easiest place to go after. Feed, of course, helps. A lot of things help, but if you switch from cows to pigs and chickens, it shifts, but it doesn't go to zero. All right.
Hello, this is Lou. I just have a question.
Sure.
Isn't there an algae supplement they can give cows that reduce the methane?
I've heard of a bunch of different things that are both in the food and how we grow the corn and what food we give them. I don't have any of the technical answers. Some of you might, if somebody wants to chime in on some of those, just kind of while we're here. But yes, there are a variety of things. Unfortunately, most of those will take probably most of this decade to get major implementation in the world. If you
I
recall
see.
that bar chart again, a lot of the agriculture is not in this country. So we are not
Right.
the only source of cow methane. And getting other countries, particularly the underdeveloped countries, and maybe some of our less friendly countries like Russia, it's going to be a lot harder.
Right. Right.
But yeah, there's a lot in all of the different areas. There's a lot of, I mean, the danger of opening up this topic is I learned, you got on the internet and throw out some of this stuff. I mean, it is overwhelming, all the stuff that's going on. But I think this focus on a couple of key aspects of methane, primarily the worldwide, global production of hydrocarbons. We're not going to get to zero hydrocarbon energy for quite a while. I don't care if we switch the whole world to nuclear, that's not going to happen this decade. But we can stop the methane that is coming from what's currently going on. Oh, so here's an interesting little graph. And again, much like all the other pie charts, there's 20 of these out there, and they all look different. They all have different numbers on them, but they are all basically the same. Methane dissipates, decomposes, or as I like to call it, has a half-life, much like radioactivity, just like nuclear materials. And it decays over time. But if you, and people like to talk about the 20, 25 to 1, you probably heard that. And I think you saw it even in the video. I think she used 25. Everybody likes to use the 25 because that's the 100-year number. And I have two comments on that. The first is, I'm not sure we can wait for it to all dissipate 100 years from now. That might just be a little bit hard on the planet. We may have to get to some of the conversations we've had in the previous couple sessions of 4 degrees, 6 degrees. If we address it in the 10-year time frame, you recognize that it's up in the 100, not 25, but up in the 100 impact over carbon dioxide. Some people say, well, no, it's not quite that high, it's only 80. Other people say, well, it's 150. But it doesn't really matter which number you pick. It's time to recognize it's a biggie. It's a really biggie. And the other thing about the troposphere and stratosphere topic, out there at 100 years, that's the methane turned into carbon dioxide and water. So methane doesn't disappear. The methane disappears completely, but the global warming impact does not, because it turns into carbon dioxide and water. So when people talk about, okay, so methane dissipates down to 25% or 25 potential impact. It does because it switched over to something else. And then you got to say, well, what are we going to do about carbon dioxide? What are we going to do about water? So my point is, it's really a lot of different ways to look at it. But if you stick in the 10-year time frame, let's stay in the 10 years, let's stay in the upfront and say, wait a minute, this is a really big number right now. And we could control it right now in like 25% of the sources, which is the hydrocarbon industry. All right, so here's kind of the summary before we go to the calculation. Now, this is the global. So you'll see now methane and carbon dioxide have a little different ratio. And so this is more like a 5 to 1 versus the 8 to 1, which was the US. And this is largely because of, as you recall, China and their coal mining. Remember, they were so high. We aren't the biggie. We're part of the world, but we're not the biggie, even though we'd like to think we are. Maybe in global warming, we wish we weren't, whatever. So let's take these two numbers because they're smaller, they're pretty good numbers. And then this other one is the impact chart, the global warming potential chart. And there's the 25 and it looks small. And that's because people like to use the minimum number, the 25. They don't really want to use the 100. And of course, the nitrous oxide and the fluorides are really biggies. And we've already in the past addressed the fluoride sort of. Not much has been going on with nitrous oxide. We need to be careful about that one. That's another whole presentation. So, so let's take the 1676 and the methane 25 and 1, not the 50 and not the 100, just the 25, okay? And realizing the first thing here is there's a lot of variety out there of data, but it's relatively a big number. And so 25, everybody agrees at least with 25. Nobody gets upset if you use 25. Use 80, people say, oh, no, it should be more like 20. All right, let's pick 25. Just talk about super conservative. That's it. And then we'll use the global numbers instead of the US numbers, and recognizing that we want to stay in this decade.
What? Oh,
What's that? Was that a comment or to what say? I'm not hearing you. Was that a comment?
Okay, that's okay. Just go on.
Okay. So here's the calculations. And I did it for global here on the left and US on the right. If you take the percentage of gas in the atmosphere times its impact, and you use the 7616 from the global and the 1 and the 25, which probably the 25 should be more like a 50 or an 80, but let's just use 25. You come up with like a, what is that, 76 to 40? You know, it's a 5-6 to 1. Methane is much more significant in the short term than carbon dioxide. Now, that doesn't mean we should skip carbon dioxide. Carbon dioxide is a really, really big factor in global warming. But there's another really big short-term one that we could grab a hold of easily, because we have proven to ourselves, I think, that carbon dioxide is not going to go away quickly. We're not going to go away from fossil fuels very quickly. But methane, we could. The US numbers are a little less impactful, but they're still, 4 to 1. And if people could get to this exact chart right here, you don't have to argue about the 25 because we picked a number that was right at the bottom. The percentages, that's pretty straightforward. Our new satellite has uncovered those very nicely. And you realize this data is what created the shift to adding methane to the COP26 goals for the planet. Here's an interesting little kind of just a really cartoonish but simplistic view. On the left, you have do nothing, up goes the warming. In the middle, let's kind of constrain things a little bit. What happens? Sure enough, CO2 is the biggie. Not big surprise there, right? That's what the conversation's all been about. But if you can actually reduce them, CO2 will sort of level out the warming, but methane will drop like a bullet. If we can constrain how much methane we put out, the impact on global warming will be immediate, measured in a decade. But in the scheme of what people talk about, this 2050 goals or the 2100 goals, it just unglues me. It's like, whoa. And our last couple presentations, we've said, we're going to get to 4 or 6 before we get anywhere near to 2050 or 2100. And this is the solution. Therefore, Biden has stepped up with the world at the COP26 and said methane needs to be the main, an additional emphasis. It doesn't mean you shift from carbon dioxide, but we need to elevate methane. So the pledge is from that group to reduce methane by 30%. Now, if you put that number on CO2, could you do CO2 by 2030? Of course not. The world isn't going to shift away from energy production by that significant amount by 2030. But doing methane, everybody recognizes, holy smokes, we could do that. That's doable, which would actually, and I don't know about this, seems a little bit optimistic, but I'll take it. We could actually hold to the Paris Agreement 2 degrees. That would be impressive. But as a goal, I think that goal makes sense to me. And this came out of the COP26 event last.
Could I raise a question?
You bet.
Why are you so optimistic that we can reduce methane when we have all of us here in Wisconsin, and I think around the country, heat our homes with methane? How are we going to get around that problem?
Heating your home with methane does not release it to the atmosphere.
Oh, no, but preparing it, especially with fracking, I went to a symposium in Chicago of the American Association for Advancement of Science years ago. This was before fracking, and they tried to measure the gaseous release of methane around wellheads.
Yep.
And they found about 50% of them were leaking.
Yep.
The industry didn't want to admit that, but the scientists revealed it. And along came fracking a few years after that. And I'm pretty sure that without the wellheads, I mean, that with the fracking, with the pressure and the solvents, that you're going to get an even worse situation with methane after fracking. So if 50% of the wellheads were leaking 10 years ago, and we've had fracking come in since then, it must be pretty obscene. And so just because we've got this nice methane pipelines coming in heating our homes, doesn't mean we can get rid of the methane right away.
Correct. No, yeah, I think there's general agreement that coal, oil, and natural gas, in the form of as a creator of or a carrier of methane, are here to stay for decades until nuclear or some other major source comes along, which probably isn't wind and solar, at least not at its current speed. But anyway, yeah, I would agree. I would agree, Richard, that maybe fracking has to stop because it's unmanageable in terms of controlling the methane, or maybe that's the only carbon generation or hydrocarbon fuel mining that we allow to dissipate methane. So I mean, we're not going to get to zero, but if we can put a major dent in the unnecessary release of methane, and fracking is got some of that in it, no doubt about it. So it depends. It depends. But the fact that it's now recognized and people are starting to say, we need to take control of this, will, you know, I have to agree. This Paris Agreement, two degrees, you know, if we cut 30%, this will all happen. There's a lot of optimism here, but it beats the doomsday discussions we've had the last 2 weeks, right?
Yeah, it does.
It's equally distorted, but on the positive side.
Okay, thank you.
But at least it suggests a direction.
Yes.
And my whole objective is to indicate there is a direction we can go, different than pure carbon dioxide, beaten up on the hydrocarbon, beaten up on the.
Can I just say one comment? This is Lou.
Yeah.
A lot of the bigger cities, older cities, the piping throughout the city is not so tight, and it gets aged, and you have some leakage. And of course, some houses may have a lot of leakage and then they explode. But it's one way to solve the problem, but not a good one. Anyway, the infrastructure of piping is how do we deal with that? I mean, or isn't it that bad? I don't know if there's a way to, if you have found out a way to tell how much of it is there.
Well, that's a good point, Lou. I mean, the whole infrastructure topic of getting the natural gas to the processing plant where the methane is taken out and the propane is taken out and things are resorted, and then the odorant is put in. So the only methane we can actually smell, well, maybe cow farts, or our own, but the only methane we normally smell is got odor in it. So at least when it's leaking in the distribution to your home, to the homes, businesses, whatever, there's an opportunity to smell it. But you're right, there's a lot of piping there, and that is not easily. That's not the one that is being focused on. It's being focused on is getting the natural gas to and or at the point where you're mining it in the first place.
Right.
I
So,
have a comment.
yep.
There are actually three parts to the oil industry where methane is a problem.
Okay.
One is drilling and tapping in. They release methane before they can cap the well.
Yeah.
And as Richard has noted, that is the big burst at the flaring. Once they've capped the well, the second problem is leakage in the piping, and the fact that they do a lot of flaring to control the pressure, and that gives you methane to CO2 off the well. That problem has been avoided by legislation because of the clout that the oil industry has. And the third, which is really unrecognized, is the fact that we have thousands of wells that have been capped, have been, quote, sucked dry. Even though there's a lot of oil down there, it's not viable to get it out. Excuse me.
In doing his phone, did he shut himself off?
Yes.
You
Yeah.
back?
Oh,
There he is. He's back. Good. Okay, go ahead.
A state like Pennsylvania has recognized that there are tens of thousands of wells that were drilled early in the lifetime of Drake's well and the explosion of individual drilling for oil. And Pennsylvania has a program to do that, but they have no funding virtually. They have thousands of wells that are just leaking methane and have been. Many are leaking oil even. And I don't know how much it is in Texas and Oklahoma and now the Dakotas, but those abandoned wells, or California, those abandoned wells are just, nobody owns them anymore, or the corporations that own them have long been dissolved, and that's just out there.
Yeah.
Absolutely. Yep. Yeah. And so the challenge from a governmental standpoint, and it gets a little more complicated on a world standpoint, of course, is funding that process. But it's not all that complicated. The good news is you don't have to develop and manufacture or facilitate creation of nuclear reactor systems or put in lots of solar or wind towers with big batteries. Not that those aren't important. They are. But if we just put money, I guess the point is, this is really just a money, not a technology problem.
Correct.
And now that doesn't make it easy, and politically, money is.
But it's a lot of money, and there's no source other than government.
Right. So that's why Biden and the U.S. Methane Emissions Reduction Action Plan, which is like 20 pages of details that include all of these things you're talking about. If you haven't been there, I'll show you that picture. But that's where these come from. So these are the headline bullets in each one of those. So this one is about that infrastructure. It's largely, it suggests the ongoing, but there's also the whole section of what do you do with the idle and the historical wells. Landfills have the goal for that is also pretty aggressive. I think this one is probably more aggressive. Well, doing 75% of the natural oil and gas, and this really includes coal, but the hydrocarbons, that's a big number, and that's a big number. But at least it suggests some goals that are big enough to maybe motivate money. Agriculture gets a little more complicated.
The plan is a lot of rules. There's no enforcement. There's no money for enforcement. Biden is completely hesitant in making it a presidential order.
Yep.
He makes a lot of orders for things, but he has skewed away from that simply because of politics.
Yep.
He is completely weak there.
Yeah. The good, bad, and the ugly is both the media to some extent, but the political meetings, the global climate meetings, have identified an opportunity. But you're really right. There isn't anybody, any country particularly, and even ours, who have gotten motivated to do something about these goals. But at least, I mean, and the goals are really only 6 months old, which in the scheme of things is short. But in the scheme of a decade, we're blowing through the decade here pretty quick. It's time to haul ass and get something going. So yeah, I don't know, but it's the most optimistic thing about climate warming that I've ever run across. In contrast, I mean, Richard talks about nuclear, and yeah, that could get us carbon free by 50 and 2100, but not this decade. And if we don't do something soon, we're going to be at 3, 4, 5, 6 degrees way too soon. Anyway, so yeah, but I agree with you completely. The goals and the at least the public now information is beginning to get out there. We'll see what politicians, which countries decide to step up to it. War times just, of course, create the heck out of things. Whoops. So
I don't know if you've ever heard it, but I've heard a saying that preventing accidents doesn't sell bandages.
yeah.
And that's,
Yeah,
funneling these funds to cap wells that have rusted open in Pennsylvania, which had a good program on that problem just a while ago on PBS. That's something that they know is there, but they're unwilling to, say for every gallon of gas, we spend another nickel capping oil wells. Nobody's able to do that. Politically, it's a dead end.
Well,
I've got a question.
as we talked about a couple of weeks ago, the dead end may be the next generation of dinosaurs. That's these two-legged things we call Homo sapiens. So
yeah,
we don't truly want the dead end.
No,
but you're right. We're headed there.
Just a quick comment, if
Yes.
I may.
Sure.
I thought NASA was putting up a satellite that really could measure methane release across the globe and map it out. I don't know. Is this part of your presentation? Have you heard anything about that? That
So
could put a lot of pressure on countries that are showing a lot of release. I mean, and this could be released up in the tundra too, up in the Arctic areas as well. But I thought NASA I heard that they were doing that. It would be a huge thing.
I think the satellite must be up there in some form, because I'm not sure where the data comes from, to tell you the truth. I'm assuming a satellite, as you mentioned, but there are global maps where I showed that bar chart. There are of the different regions of the world. There are maps of those same bar charts that show. It kind of looks like the COVID maps, where it's different colors, 12 different colors of red.
Sure.
And it's really interesting to see those. And there's one for CO2, there's one for methane, there's one for water. There's, they're all the different greenhouse gases. And I'm not sure where that data comes from, but a satellite seems like a good candidate for coming up with that information. Just
there are satellites that do pick up.
Yeah, okay.
NASA put it up in actually 2020. So
Okay.
a couple years ago, that satellite went up and is tracking it and reporting it.
Yeah, okay, so, you know, the answer to your, is it in here? No, I've come to the end, at least of what I decided to dig out, because we're at an hour and it seemed like enough. There is a lot of really exciting information if we could just get the focus on methane and recognize that the international community is interested, apparently, at least at the conference level. I thought this was interesting in that the International Energy Agency says, yeah, methane must become a priority. However, we're going to be using at and increased hydrocarbons for at least the next decade or so. So that's actually not surprising, a little disappointing. And of course, due to the near-term warming potential, this needs to be a focus. However, the world is not on track to address it. The US is beginning to, and this bottom line is, we'll see. You know, if, the big word in that last paragraph is the if, which I didn't highlight. If the efforts to address the oil, gas, and programs and regulations and the monies and the things you're talking about happen, then we'll have, but there's a lot of ifs all up and down this, that's for sure. And then kind of closing, that was going to be my last slide, but yesterday in the news, there was this from the new COP27, which will happen in Egypt here, I think in July. There's some pre-meetings on that. And two interesting comments came out of that. One was, despite the growth of renewables, things aren't going the right direction. They're going up rather than down. And my reaction to that is that may be an opportunity for methane actions. Now, to all the things we've talked about, the actions are going to be expensive, but the technology is not complicated. Isn't we have to develop anything. We don't have to come up with Gen 4 reactors. We don't have to come up with new super solar or super wind. We just need to spend money and get political action. Yeah, like that's easy, but at least it's an opportunity. And then that last one, we're not going to unplug the hydrocarbons until we have a whole new energy source. And that's where Richard comes in with his Gen 4 reactors. We've got to come up with, if we're going to do carbon free by 50 or 2100, which is a parallel problem. It's the CO2 side of the problem. It's not going to happen by just unplugging things and say, there, we're not going to use them, because people would have to change their behavior. Not likely to happen soon. And there you all are. One thing I could share, let me see here. The easiest place to see it is here. Where's my methane links? I got 27 links to everything. The danger in this is you come up with so many options, it's a little hard to figure out which one is which. There's a UN plan and then there's the US plan. I like the US plan because we've talked about it the most. That's about the only reason I like it. Let me come back to you all, and then I can share that. That's this one. So does that big blue screen come up?
Yep.
Yep.
All right. And this is the it just goes on and on and on, of course. It's a big PDF with all of these topics in it. Getting the job done, what are all the restrictions, the cappings, that, you know, you see all the different titles, and it's not that big. It's only like 15 pages long. And then there is a really nice one that somebody has created, which is a summary. I wonder if it's going to pop up here for you. Does that pop up? You see the publications? Whoops.
Yep.
Yep.
So this is a nice document also, which is the same information, but done by whoever these people are. Anybody know who these people are? The Beverage and Diamond? But anyway, they did a strategic overview, key takeaways, and that's where I did the copy and paste of the key takeaways. And yeah, it's missing a lot of the details, but it gives you, all the different topics that are in that big report. All right, enough.
Can you give us those link to those two documents?
Sure
please?
can. Well, yeah, and let me try another one, see how many you really want. Here's the UN version. That came out about that same time frame. These are kind of the ones I decided to save. These are kind of my big three, which is the US, the UN, and this summary one. And it just goes on and on and on, of course, as you can easily imagine. And this one was put out by, I don't know, anybody recognize these? Go away. Anybody? Come on, throwing up pop-ups. Can you see the methane reduction key?
Yes. Yep.
Yes.
So, and it kind of shows, where things are all headed. This one, this one's the one that has about the ice in it and a few other things. Probably the other three are the best three. I could forward all three of those to Richard and he can send them on to you. Sound like a plan? Yeah. Okay, that's enough. What those will do is they all have links in them. And by the time you're finished, your brain will be overloaded, or maybe not. Maybe y'all have big brains and they never overload. Mine did. And being an engineer, I'm looking for the engineering solutions. All this science and data is kind of at one level wearing me out, but on the other level, it feels like an opportunity that has not been effectively pursued. And so I was kind of excited to see that the COP26 finally started using the word methane. And so back when Richard was saying, what are we going to do in the spring? I said, Richard, I've seen a new word. I have no idea what it means. And he said, oh, so I told Richard, I said, find yourself a methane expert. Ha! He said, what, I forget what you told me. You remember what you said? Anyway.
I think I said I didn't want to do it, and I was looking for somebody who would. I'm so glad you did. It's something we all need to know.
Yeah.
And when I'm kind of involved with oceans and nuclear and various things like that, and so I'm really glad that you did this, Mert. It's a lot of work, and I think. I really wanted to say, I've said it before, and I'll say it again, that I really appreciate this group volunteering. We always can go back and get professors from the university, and they've been good. But I think one of the things I like about various members of this group is that we can each volunteer to do a little something besides listening and discussing. And I don't expect every last one of you, but I appreciate those who have stepped forward this spring very much. And I'd like to see it continue into the fall. Also, if any of you have names of professors or experts in medicine that you think would be good speakers, please bring them forward, and I'll with their names and emails or phone numbers if you have them, so that we can start on this fall. I've already come up with a few ideas, and but I think it's been a very good spring so far. My biggest problem has been using the hybrid system. We're going to go back to that next week, and I think I'm due. Is it next week? I think it is. Let's see here.
You swapped with me, Richard. You're up next week.
Yeah, I'm on glaciers, global impacts of glaciers next week. So I'm hoping that we can get it working from Oakwood. And I think it would be nice for Oakwood. We don't have to do it, but there is a nice atmosphere there when we have direct conversation. I think that you were very successful today, Mert, in getting good feedback from everybody. So it wasn't just a lecture format, and we had good interactions throughout.
I see 7 chats. You might want to pick up on those. Yeah, Lou?
Oh, thank you. Yeah, I should do that.
Okay.
While you're looking at that, I have
I'm
two
not
items. Thank you, Mert. Very informative. Looking forward to the links. Last night I watched a PBS special on squirrels, and how that applies to this is the fact that they determined that in the fall, a squirrel's brain grows because it needs the extra brain space to locate the nuts that it buries in the ground.
Yeah.
And in the spring, after it has gone through all of that, the brain shrinks a bit. And it's a substantial portion of change. And it's a very interesting study. So the more information we put into our brains, perhaps the more it grows.
There you go.
I have heard that brain health has a lot to do with using it. Good point.
Yes.
And maybe,
So this is Tony. I was wondering if I could interject a couple of things. First, Mert, definitely I think you did an excellent job. My original degree was in engineering, mechanical engineering. I moved into IT in 1969. So I've always been close to manufacturing companies because every one of the companies I worked for were also manufacturing companies. But going off on a couple personal experiences, specifically as far as methane is concerned. So we bought our house 12 years ago, and I was walking around doing some yard work outside, and I got a smell that wasn't appropriate as I moved close to our particular a meter as far as where the gas comes in. Called Madison Gas and Electric, who provides it. They came out. Yep, it's definitely leaking. Not a serious leak, but it's leaking. We definitely need to replace it. They check them periodically by driving through the neighborhood and actually getting out and checking. That's my impression or understanding. Okay. Leakage can also be detected as far as usage if it's too much, but unfortunately, they definitely, if they're not caught in time, they'll explode. And of course, we've heard that on the news many times over the years. Now, when we moved into the house we moved into was around 30 years old at that time, 28 years, I think. So the gas, water, the hot water heater, air conditioner, and furnace all were in need of replacement. We knew that when we were going to be moving in. Not that they were out completely, but they were dated and they were totally inefficient. So we ended up looking at what's called, some people call it geothermal heating. Most people, if they look at the proper term, it's a heat pump. Heat pump eliminates the need for gas, okay, as far as in a household. You run primarily on electric, so you want your electric source to be as clean as possible. Nuclear is the best, we know that from our discussions. But so eliminating your furnace can be done. We looked at it, even with the offsets that were available. It was, I think, something like $50,000 more to replace them at our particular facility going back 10 years ago. My impression is that price has dropped significantly. More and more people around the Madison area are changing over. I've heard of at least 2 or 3 of them that have done it already. And the delta difference is more in the area of about $10,000 to $20,000 after the rebates. So you might want to consider the next time you're looking at replacing your furnace, take a look at a heat pump. Some people, again, call it geothermal. Next one, as far as cows, my family, when I married into with my wife, they are primarily farmers, and they are primarily milk. So they definitely have cows, and they do a very good job of trying to manage their capturing of feed and various things. So a couple of years ago, Australia came out with the concept that seaweed added to feed for cows reduced somewhere in the area about 80% of the methane for the cow. That's a research study that was done, and it's been promoted and being used, but it's not thoroughly analyzed yet. A recent article indicates that the actual impact to the cow is a little bit unknown with changing the feed too much seaweed, and the potential that it can have down to us impact if you're eating a cow may not necessarily be the best for humans to eat that cow that's been on that feed. I don't know that for sure. That's just a recent article. So anytime you have, let's say, science taking over and researching what's the best direction. Is you definitely have to leave it play out for a bit. The last thing is, as far as stoves, the next stove we will buy definitely will not have gas on it. Our current stove the oven is electric and the stovetop is gas. Every time you light your stove, a little bit of methane is released in the process of getting that particular burner started. That methane that's released is not good for you in your household if it's a good a sealed house, if it's not vented properly. So you got to watch out for that methane in your household. So moving towards electric stoves is something else that has to happen sometime in the future. And those are personal actions that we could be doing that would help reduce the methane. And in the past, again, there are government programs that help subsidize it and reduce the cost. I don't know of anything on the stoves at this point in time, but I have a feeling that might be coming in the future. So, because the downward impact, in regards to gas leaking somewhere through this, the system that's providing it to us, definitely is an impact at various locations. So,
Yeah, I think
that's my comments.
My daughter-in-law is a chef, and she definitely will not cook over electric. Gas is just what chefs prefer for the variability and rapidity of doing a good job quickly.
So it's just like the people that continue to eat beef, because beef is one of the worst things. There's 1 billion cows on the earth, not 7 billion, but so if you continue to eat beef, you continue to say there's no impact that I'm concerned about as far as global warming other than other people. And the same thing as far as people cooking, of course, and the same people that don't want the windmill in their, off the shore, right next to their luxury home that's on the coastline until that coastline gets flooded. And they might have a different impact on it. So it's each of us and the impact that it personally affects us that you have to look at how's it affecting society as a whole for the long term. So,
yep.
That's again my comment.
Could I say something?
Yeah.
Yeah, go ahead, Dorothy.
Back to the gas stoves. I too have a gas stove and I appreciate the speed of responsiveness. However, I think the average household, including mine, the food is not going to, I'm not a professional chef. The food is not going to be that different if I go electric. So the average household shouldn't have as much of a problem unless they fancy themselves to be gourmet chefs. We could keep the gas stoves for businesses for whom it makes a difference.
That's a good point. And I think the magnetic induction stoves are a more efficient way of using electricity than resistive heating that are in typical electric stoves. So that's another alternative. And they apparently work quite well and quite efficiently. So that's another alternative. I did give a talk about, oh gosh, not quite 10 years ago, maybe 8 years ago, I reviewed a book called The Answer. And this fellow is no longer with us, but it was a fascinating story. He proposed using the current gas lines, and instead of sending methane through them, send air or nitrogen, nitrogen being 80% of air, so you could do one or the other. And that gas could turn small motors in everybody's basement. The gas would be pressured by nuclear reactors every 35 miles and small compact reactors and underground pretty much. And so this air would come in, turn a little pump in the basement, and that pump would provide all the electricity and that the house would need, enough to provide electric heating or heat pumps or both as needed. So that was his way of getting rid of the fossil fuels. I don't know if anybody's taken it seriously because the pipes that we take now that distribute methane, I think it's at a fairly low pressure of about 2
That's the whole
atmospheres.
point.
And I
It's
think
too
you'd have to increase the pressure quite a bit.
Yeah, and they wouldn't handle it. They wouldn't handle that pressure.
I think you're
I don't
right.
think-
Yeah. That's
You're
Why
probably,
at the
not
end-
just
You're
distribute
at the end of the
electricity?
pipeline, yours is not going to turn.
pardon?
If you're at the end of the pipeline, yours is not going to turn.
Yeah, that's true.
Well, no, they're intentionally low pressure. I mean, that's
Yeah.
the way they're designed. You don't need a lot lot of pressure for methane, for natural gas.
But if you put air through them, you don't think that the
They
regular.
wouldn't hold up probably, but why not just use electricity? Why do all that? You just use the infrastructure, just use the electric lines you have. I don't know.
Yeah, I think that's probably going to be the way we'll go. Yeah.
But you know, my point I wanted to make was, how do you need to replace 3 appliances: your stove, your furnace, and your clothes dryers, and who's going to replace? I mean, new construction, you can maybe legislate that in somehow, but how do you do that with regular homes and people? How do they afford that? How do you segue that in or layer that in to get rid of that usage? I don't know.
Nowadays, we just put an incentive there.
Yeah, maybe, but that's, I mean, those 3, furnace is a pretty expensive item, or heat pump or whatever. That's going to be more costly, I would think.
Yep. It's all going to cost more. And utilities are required to change gas meters on a periodic basis. I've just had one changed at one of my buildings, and I just got a letter from Wisconsin Electric that they're going to come and change mine.
Speaking of that, I hope I didn't cut you off, Stephen. But just a quick little thing. I got 2 summers ago, my townhome got hit by lightning on the top stack, and the voltage ran through the house, messed up this and that, but it ran through the piping, and the whip to my dryer got a little hole in it, and it started leaking gas. Wow. And my daughter got very sick from that just in a short period of time. If you ever get hit by lightning, check that you don't have a gas leak. Maybe that's a very rare event. I don't know, but
I have a thought on that. When I bought this house, I had it inspected, and because we have that kind of orangish yellow flex,
that's a whip. That's a whip.
Okay, to the 2 fireplaces, in contrast to everything else, which is hard pipe. The inspector said you must have the hard pipe grounded before it goes to that flex, or you will have, and it doesn't take lightning, he said, any small amount of electric surge in your environment, whether it's from the outside or whatever, he said, will punch small holes in that pipe. So I had to put on a 2-gauge wire at each of the places where it went to the flex. So if you don't have that grounded, be sure to check that, because it's not about lightning. It's about anything.
I've got it grounded by my meter, but maybe it's not grounded right. I don't know. But that's lightning. That's right. Lightning. That's a lot of voltage with lightning,
Well, that's why I put in a wire the size of your baby finger.
Yeah.
But he said you need to put it right at that joint, because if there's any electrical induction that happens after, I mean, it all comes out of the ground. So I said, it's all grounded outside. He said, not good enough. You've got to ground it right where it goes to that flex. Well, anyway, that's
case in point. That was what happened with me then.
I was surprised when he said that. He looked at that and he said, those aren't grounded. I said, what are you talking about, dude? That's gas.
So it has to be grounded close to the pilot light on those gas log fireplaces?
He said the place to ground it is before it goes to that flex tubing.
At the end of the metal piping.
Right.
Okay, which is back in the wall. I guess I can't see that to check it, huh?
I don't know about yours. Mine happened to be visible right over the furnace where they switched over from hard pipe to the flex, because that's where the valves are. You have a valve shut off at your hard piping. Yeah. It's where the valve that shuts the hard piping off before it goes to the flex, not the one at the other end by the appliance, but where it shuts off. Anyway,
see,
it'll be down in your mechanical area in your basement.
Right.
It's next to the appliance, wherever it is. Clothes dryer. Mine was a clothes dryer.
But the clothes dryer
was upstairs. The thing is, in a way, he's right, because that voltage can catch anything as it's traveling through, and if you don't have it grounded right before, you could have a risk factor. But it just catches, the current just travels all over the place. You don't know what the path is going to be.
Yeah, I think to your point, Lou, the shorter one is at the gas dryer where the hard pipe comes out of the floor. Mine,
Right.
the fireplaces have probably a 20-foot flex pipe on them.
Oh, it's that long. Oh, man. Yeah.
Well, because it starts at the furnace and goes through the wall, over the ceiling, up to the second, I mean, it's
Oh,
a
wow, wow,
long,
wow.
long, he said, that's really
Mine
hazardous.
is only a couple feet. It was, I mean, it was brass, and I thought, well, because it wasn't coated, coating doesn't probably matter. The plastic coating.
Someday when you have time, I'll tell you about when our house was hit by lightning.
Ooh. That is never pretty. I've heard of a few of those.
No,
That is never pretty.
not. It's not. A lot of things had to be replaced.
Yep.
Kind of while I got your all attention for just a second.
About started the house on fire.
Oh, no.
Yeah, I've heard that's the downside of it. So you asked for the 3 links. Is there any interest in also having the link, the PowerPoint slides? Do you
Yes.
anybody need
Oh,
that?
sure.
Yes.
Okay,
Absolutely.
I'll put all 4 of those up.
Okay,
Thank you.
Thank you. Thank you.
Very good presentation, Mert.
yes, thank you,
yes.
Mert. And
Yeah,
this,
thanks, Mert.
this talk is being recorded and will be available at platomadison.org. So
So are there any of the what are they called? Any of the chats that need to be talked about? So I'm
read
scanning
them, and I
through
think
them.
we've covered most of them.
Feels like, but whatever, if you want to add to them, whatever, let me know. Or talk to
Yeah.
yourself, talk among yourselves, whatever.
We had some good vibes from George Erickson. He says expand nuclear power. And Gary Embram says there's a link. He calls it bigthink.com/strange-map/methane-emissions-map. So you can, I think he Googled methane leakers and found that link there. Alan Pentecoff said that he read an article supporting fracking that pointed out that the faucet on fire in the documentary Gasland was fake. Fake in that the tap water with gas was not due to fracking, but due to the natural occurrence of gas in water in areas where there are gas and oil deposits. The home where the scene was shot had this problem before fracking began. So just a footnote about a different situation where the faucet was on fire. I think we've all seen that link. Doug Edwards says an induction stove may have the same ability to control cooking heat as does a gas stove. That's been my impression too, Doug. Thanks for that remark. My wife likes hers and she likes it just as much as any gas stove that she's used in the past.
But you got to get all new cooking utensils.
That's a good point. Yes, we did that. I've got a picture of them after we brought them in and put them out on the counter. So there is some cost there, absolutely.
What do you mean by utensils? Pans or?
Yeah, they have to be steel. They have to be steel. Copper and aluminum won't work.
I see. Have to be steel.
Yeah. Good point. Well, look, it is 11:30. I really enjoyed this and appreciate everyone's input. And next week will be it won't be so mechanical. It'll be kind of visual, but interesting to be aware of the beauty and the hazards of glaciers around the world. And then I'll have a couple of other little tidbits at the end. So we'll see you hybrid from Oakwood next Monday morning at this time, 10 o'clock.
Hey, Richard, I had a quick question.
Yes.
What was the ratio of the greenhouse gas warming potential of water to CO2? Because I was going to do a calculation with that.
I did not see that one in any of my slides. I think it probably went by. So the answer is I don't know. That slide where I showed the different ones did not have water in it. So I don't know. Did you try?
Water is always there in the background. There's water, a huge amount of water in our atmosphere. And so I think it's irrelevant because it's always there. It has a very short cycle. It only stays for a couple of days. And I think it's really irrelevant. It's simply in the background.
Oh,
Maybe that's
okay.
why it-
Because I was thinking, you know, in the stratosphere, when you have the methane breaking down to CO2 and water, I was just gonna, you know, use the stoichiometry and then just do the calculation of which side of that equation are we better off being on? That's just the
I'd
point.
focus on the CO2 and just forget about the water.
Okay.
Yeah,
I didn't learn that about that one in engineering school. So go ahead, Lee. Send us how that works.
Okay.
water is kind of a wash. I
Yeah.
agree with Richard. It just isn't that big of a factor. I don't think.
Water is not a wash. Actually, the thing with water is that it's always there,
Exactly.
and it's there in a constant amount. It's in, I won't say it's in exact equilibrium with the oceans, but it's actually very significant.
It is
But the thing is,
significant.
it doesn't change. It
I
doesn't
think you're-
change like we're seeing with CO2.
I
But
think
in the
that's-
stratosphere, it does though. In the stratosphere, because it's said
Mhm.
in his presentation that, you know, naturally you wouldn't have any water in the stratosphere, but because we're putting, you know, methane up there, which then dissociates, that then we do have water up there. So I think it is significant.
well, I think
No,
what
Yeah,
happened-
and then
well,
it crys- then
water
it
is very
crystallizes.
significant. I'm going to tell you that just from what I learned taking a meteorology class, that water is very significant. And
Sure, nobody's saying it's not insignificant. What we're saying, what Lou said when he meant, well, when he said wash,
Sorry.
what he meant was that it's there in such profusion that the tiny bit of water released from the degradation of methane is insignificant compared to
Oh.
the giant volume of water that's up there already.
But there's not any water in the stratosphere normally, he said.
Sure there is.
Oh, yeah.
Yeah,
Go back to that slide. Well,
Look at
maybe
clouds.
you don't want to take
What's in
time to do that,
clouds?
but
What's in clouds?
It's
the
water.
stratosphere
This
is
is
higher
this
up.
is way above the
So
cloud.
there are clouds at the
Yeah,
stratospheric
they're in
level
clouds.
as well.
Yeah.
Certainly there are.
Ionosphere.
Cirrus
What are
clouds
we
are up at
into
that.
when we're up in an airplane and you see the clouds end? I don't know what layer that is.
Oh, okay.
You know what I mean? It gets too cold. Pretty soon you get up too high and it gets too cold, right?
And you can get some ice crystals up there in this, along with the cirrus, sure. In fact,
But
that's
the methane goes above that and then disassociates.
Right, but that
And
methane
that's
would
the
be,
problem.
you know.
I think it's the
one of
fact
the
that the
ways
methane
water
goes
gets up there.
higher and then disassociates, and then you have water that crystallizes.
yeah.
okay.
Well,
Well, we'll carry on this conversation.
Okay.
In case you didn't notice, my objective is to stir the topic up.
You sure
Because it
did.
has not,
You did,
I mean, we
Mert.
talk
That
about
was very good.
CO2. We talk about CO2 all the time. It's time to start talking about methane, even though I have only 2% of the information. My objective was to stir your minds up with some superficial slides and then delve off into the internet.
there you
Well,
go.
you stirred
We're
us.
You
stirred.
did that. That was great. You did
Mission
that, Mark.
accomplished.
Thank
We're,
you.
we're shaken, not stirred.
Next
Okay, I'll take
talk
whatever
about
goes for
frozen
you.
water.
Just go looking for more. Keep it alive. Keep the topic alive.
Okay.
Okay, everybody. Next week,
Bye-bye.
frozen water.
Bye.
Thank you.
Okay.